All right, this is Geometry, Chapter 3, Section 7. Equations of lines in the coordinate plane. And let's do, these are your notes. You're turning them in for credit. Make sure your name and the date and the class geometry is on there. Our learning objective for today is to graph and write linear equations. So you should, in your notes, definitely have a graph. So as you guys are saying, do you want me to include the graph? And I say yes, because that's our learning objective. So we've talked about it before, but slope is a concept that comes up over and over again in math. So it was prevalent in pre-algebra, it's prevalent in Algebra 1, and it's also prevalent in geometry. This is one of those things, if you don't have it memorized yet, I would definitely make a flashcard. Get this information in your brain, because the more you have to, this is one that you would have to look up over and over and over again. So slope of a line is the ratio of the vertical change, and ratio just means fraction, which is the rise, to the horizontal change, which is the run between any 2 points. Symbolically, if a line has the points x1 and y1 and x2 and y2, then the slope, rise over run, is the difference between the y's, y2 minus y1, over the difference between the x's, x2 minus x1. So there are 4 different types of slope you will encounter in your adventures in slope. The first one is positive slope. The way I like to think of it in terms of exercise. So if I want to burn calories, which is a positive thing, my little guy, he walks here, he's like, what's up? He's going to be walking uphill. He's like, what? I'm uphill. He's positive. Downhill is negative. If I'm going downhill, I'm like, whoa, this is so easy. I'm not burning any calories. Whoa. And I'm the best stick figure drawer. And then zero slope is a flat line. There's nothing going on. Flat, zero. And then undefined is a vertical line. So 4 different types of slope. All right. So there are 2 forms of linear equations we're going to be looking at. And please only write down what I highlight to save yourself some time. The slope slope-intercept form is a y equals mx plus b, where m is the slope and b is the y-intercept. The point slope form is y minus y1 equals m times x minus x1. Everything in black on this point slope form stays. This green guy, the y1, is the y coordinate of your point. The m is your slope, and the x1 is your x coordinate. I know it's really tempting when you see all those x's and y's to try to put numbers in for everything, but if you put numbers in for everything, you wouldn't be left with an equation. It would just all be numbers. So you want a y and you want an x and you want an equal sign when you're putting together an equation. All right, so go ahead and put this grid on your paper. Or if you have graph paper, even better, put your x and y axis on there. This is your x-axis. This is your y-axis. And try to get as accurate a graph as possible. When we are doing graphs, it's terribly detrimental if you try to free-form your graph. Always better to have graph paper. If you need graph paper, let me know. I will be more than happy to give you graph paper. try to avoid freehanding graphs as much as possible, especially if we're going to graph 2 points, draw a line, and try to get an intercept out of it. If we don't have an accurate graph, that's near impossible. Okay, so we're going to graph some lines together. The first line that we're going to graph is y equals 3x plus 1. So go ahead and write that equation. This is in slope-intercept form, so we're going to use the slope and the intercept to put our line together. Our intercept is at 1. So we go to our y-axis and we locate our y-intercepts. So our y-intercept for this line is at 1. Then our slope says we're going to rise 2 and run 3. I'm making just little dots to mark my path and big dots for my actual, where my line goes. Rise 2, run 3. I'm out of graph on this side to make sure that I keep my continuity and I keep my graph correct. I'm going to drop 2 and go backwards 3. I'm going to follow the pattern all the way across my graph. Then please take a straight edge. If you can draw a straight edge, it's better to draw a straight edge than not. Take your straight edge and draw your line. If you are finding yourself without a straight edge, there you have about 100 of them in your notebook. They're called paper. There's a bunch of straight edges rolling around. Anytime you can make a straight line, please let's make a straight line. Use rulers, what else? All right, so that's the graph of A. The graph of B is in the point slope form. So I'm going to pull my point out of it. So it says y minus y1. So my y coordinate is 3, and my x coordinate x minus x1. So essentially it says whatever I have as my x1, I'm going to do the opposite. So my x coordinate is actually -3. A little bit harder to find that one, but just remember it's opposite. It has a minus. So my coordinate is at -3, 3. So I'm going to go back 3 on the x-axis and up 3 on the y. And then my slope is -2. Because I like my slope in terms of rise over run, I'm going to put it over 1. Okay, just to reiterate, because it's a minus in the formula, it's opposite when we go to graph it. So our coordinate is going to be opposite the signs that appear in the formula. It says y minus 3, so the y coordinate is going to be at +3. It says x plus 3, so our x coordinate is going to be at -3. So then our x coordinate is at -3, and our y coordinate is at 3. And our slope is -2 over 1. So I'm going to go down 2, because it's negative. Negative means down. And then to the right 1. Down 2, to the right 1. Follow that pattern until I run out of graph. And then once I run out of graph on the right, I go and go the opposite way so I can make sure I run out of graph and keep my line consistent. All right, so let's draw a straight line. And that would be blue. Awesome. All right, 2 more lines, so we're going to do this process twice more. If I look at the graph, y equals 3x minus 4, our y-intercept is negative 4, and our slope is 3. I like it over 1. I'm actually going to use black this time, so look for the black line. So my y-intercept, I go to my y-axis and I look for negative 4. He's right here. And I want to go up 3 over 1. Once I'm out of graph on both sides. And I go a steep line. The larger your slope, the steeper the line you're going to have. It's awesome. Okay. All right, and then let's try this point slope form again. We haven't used point slope a whole lot, so it's understandable if it gets a little bit confusing. So in this B, we want to go, what's our x and our y coordinate? Our y coordinate is going to be the opposite of this one. So the opposite of negative 2 is positive 2. And our x coordinate is going to be the opposite of minus 4, so it's going to be plus 4. And our slope is negative 1 over 3. When your slope is already negative, it doesn't matter top or bottom who gets the negative. If I wanted, I could write it as 1 over negative 3, but in this case, I have no problem writing it negative 1 over 3. Okay, so let's find that coordinate. So we got to find 4, 2, so 1, 2, 3, 4, up 2, that's right here. And we are going to go down 1 over 3. I'm going to fudge this point a little bit because it's off my graph. So I'm going to follow that, ran out of graph, I'm going to follow that same pattern backwards. I'm going to go up 1, back 3. And I have this nice line up here. So let's get my straight edge. Oriented the right way. Oops. I'll move. Those points. There we go. Not the graph. How about my ruler? Perfect. Okay, he's just not deciding to go on my straight edge. He is fired. Okay. So now I have a nice purple line here. And by the way, little trick for today, the thicker the line you draw, the more mess ups it covers up. So if you make a nice thick line, you won't see that we got off track here. Anyway. Okay. Now we're going to go, we're going to be given information and have to write equations. So I'm going to rewrite my 2 equations. So I have them here as a reference. A says, what is an equation of a line with slope 3 and y-intercept negative 5? I'm going to use slope-intercept. To solve this problem because it gives me the slope and the intercept. So y equals, here's m and here's b. 3x plus negative 5. Now, we are getting to a place in our math maturity where we know that plus a negative is the same thing as minus. So we're going to write, instead of plus negative 5, we're just going to write minus 5. And when you answer these problems on a quiz, I will expect you not to write the plus negative 5, but to write just minus 5. And that's how you get the correct score on. All right. Question B says, what is the equation of a line through negative 1 comma 5 with slope 2? In this case, I'm given a point and a slope, so I'm going to use the point slope. So it's going to be y minus y1 equals slope times x minus x1. So this is x1 and y1, and slope is 2. So I'm going to go y minus 5 equals slope times x minus negative 1. Once again, you guys are mature enough to know minus and negative 1 is the same as plus 1. So we're going to go ahead and write the plus 1. We're going to do each of these one more time. In A, it says, what is the equation of a line with slope negative 1/2 and y-intercept 2? So I'm going to go y equals slope times x plus my intercept. And then B says, what is the equation of a line through x negative 1, y 4, and slope negative 3? So I go y minus 4 equals slope times x minus negative 1, but we're mature enough to know that this is the same as x plus 1. 5, I think. Okay, so now we're going to get even more sophisticated. We're going to put our pinkies out and talk in our sophisticated voices and write an equation using 2 points. So now we're backing it up. We're not going to have a slope. We're going to have to find the slope between 2 points, and we do that by subtracting the y's and subtracting the x's. Once we do that, then we can use the point slope to write an equation. All right, so look at this little graph here. I have 2 points. Let's find the slope. I'm going to say, I always go point on the left. Whatever point's on the left is going to be x1, y1. It's really arbitrary, and it doesn't really matter which one you pick. So the point on the right for me is always x2 and y2. I'm going to put them in each of these spots. y2 is 5. y1 is negative 1. x2 is 3. x1 is negative 2. Simplify, simplify, simplify. The whole reason in 5th and 6th grade we do directed numbers is to prepare you for this moment in your life when you have to simplify a slope. Minus a negative means plus. When I simplify this down, it is 6 fifths. My slope is 6/5, so that's what goes here. I am going to pick this to be my x1 and y1. Could I pick the other point? Yes. Am I going to? No. So my y1 is negative 1. And my x1 is negative 2. Everything else in this stays the same. So I just take out the y1, the slope, and the x1, and I leave everything else. So now we simplify, 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 because minus the negative is the same as plus. 6/5 is 6/5, minus a negative is plus, and I have the equation of my line. And can I write it in slope-intercept? Take a look over here. This line does not cross the y-intercept at a nice corner point, unfortunately. So I don't want a fraction. I don't want to you never ever want to guesstimate an intercept and then use it in your equation. Because if you guesstimate and then try to use that equation to predict a number down the road, your prediction is going to be a guesstimate and you're going to get it wrong. So go with the for sure thing. Go with the exact numbers and don't estimate. All right, what is the equation of the line in problem number 4 if you use, oh, we did that one. So we're going to use 3, 5 in the last step instead of -2, 1. So essentially they're asking us if our slope is the same and we use coordinate 3, 5 as x1 and y1. So then it goes y minus y1 equals slope times x minus x1. And then B says rewrite the equations in problem 4 and part A in slope intercept form and compare them. What can you conclude? All right, so we're going to take our equation and I'm going to distribute this out. So for B, I'm going to distribute out and have y plus 1 equals 6/5 x plus 12/5. I'm going to subtract 1 from both sides. I get y equals 6/5 x plus 12/5 minus 5/5. Finding a common denominator. So at the end of the day, I have y equals 6/5 x plus 7/5. Right, now I'm going to do the same thing with this guy. I'm going to distribute out the 6/5. So I get y minus 5 equals 6/5 x minus 18/5. I'm going to add 5 to both sides. I'm going to get y equals 6/5 x minus 18/5 plus 5/5. All right, so it's negative 18/5 plus 25/5. What's 25 minus 18? Ooh, 7. Yeah, so this is y equals 6/5 x plus 7/5. When I put them in slope intercept form, what is the outcome? What can I conclude? They're the same. That's right. So they're the same. It is okay to use either point. All right, so writing equations of horizontal and vertical lines, mega easy if you know the rule. I promise. Mega easy. So when we look at this graph here, what are the equations for the horizontal, which is the one that goes with the horizon, and the vertical lines through 2, 4. So let me tell you that horizontal lines are always y equals our x coordinate. So this is x1, y1. We use the same naming convention. And then vertical lines are x equals y1. So when it says what is the equation for the horizontal and vertical lines that go through this point, the horizontal line that goes through 2, 4 is y equals 2. The vertical line that goes through 2, 4 is x. It's opposite. Sorry. I take it back. Get your erasers out. It's opposite. Get your erasers out. It's even easier because it's opposite. Y equals y1 and x equals x1. Alright, leading you down a crazy path there. Okay, so the equation through the line, through the point 2, 4 is a y equals 4. And the vertical line, the one that goes up and down, between, that goes through the point 2, 4, is x equals 2. So it's actually the coordinate. The x goes with x and the y goes with y. It's not flippy, changey, rearrangey. All right, so if we go and apply that to 5a, what are the equations for the horizontal and vertical lines through 4, -3? Well, I'm going to have y equals -3 and x equals 4. Can you write the equation of a vertical line in slope-intercept form? So let's try it for here. Slope-intercept form is y equals mx plus b. So in this case, the slope is, so let's just look here. I rise 1 and I run how many? 0. So the slope would be 1 over 0. And what's my y-intercept? Where do I cross the y-axis? I have no y-intercept. So you can't use the slope-intercept form because I do not have an intercept. I also have an undefined slope because we divide by 0. When your run is 0, you divide by 0, and everybody knows that dividing by 0 is what's going to cause a zombie apocalypse. The world is going to end. So we cannot divide by 0. It's against the math laws. So because we have an undefined slope and no y-intercept, our slope-intercept form completely falls apart when we try to apply it to a vertical line.